Okay, we're going to have a look at how to calculate the arc length of a circle. Before we do that, we're going to link this to the circumference of a circle. Circumference. Okay, this is a formula you should know. To work out the circumference of a circle, we do pi times the diameter, and usually that's shortened to pi d. So we'll have a look at one example first where we've just got a normal circle where we want to calculate the circumference. Okay, so we've got a circle, and I'll take that shape off, and let's imagine that we're given this information from here to here. Remember, this length from the circumference to the centre is called the radius, and let's say that this bit here is 6 centimetres. If we wanted to work out the circumference, we would use our formula. Circumference is equal to pi times the diameter. So circumference is equal to pi times the diameter of 12. Remember, diameter would be the distance that goes the full way across, so 6 times 2. And if you just do that in the calculator, pi times 12 into 1 decimal place, that is 37.7 centimetres. 1 decimal place. Okay. Essentially, what we have calculated there is we have calculated this length around the outside, almost if you like the perimeter of the circle. Let's look at a semicircle. What would happen with a semicircle? Okay, not my best drawing. Let's imagine we wanted to work out this length here. Okay, let's say that from here to here is 7 centimetres. Okay, so we want to work out the curved part, that's part on the circumference. So the formula for the circumference is c equals pi d. But that would be if it was for a full circle. That would tell me, essentially, if I use this formula, that would tell me that full length. But I've only got half of that. Okay, so that's why we're going to do a half pi d. So we're going to do a half times pi times the diameter. Remember, the diameter is the distance that goes the full way across from one point in the circumference through the centre to the other. So the diameter is going to be 14. So the circumference here is going to be 22 centimetres to 1 decimal place. Okay, we'll do one more example and then we'll try and link this to arc length. Let's imagine instead of a semicircle, we've got a quarter circle. That's not bad. And let's imagine again, we want to work out this curved part here. Okay, and importantly, because it's a quarter circle, this bit in here is going to be a right angle. Okay, so to work out the curved part of a circle, the circumference, we would do pi d. But pi d would tell us the full circumference. We only want to work out a quarter of that. So that'll be a quarter pi d. Let's imagine that our radius is 8 centimetres. Okay, so we are going to do a quarter times pi times 16. Remember, if this were a full circle, the diameter would be the distance that goes the whole way across, 8 and 8, 16. So that's going to become a quarter times pi times 16, that's pi times 4, which is 12.6 centimetres to 1 decimal place. But let's imagine we've now got a problem like this here, where I'm just going to draw. I'll try to do that bit again. Let's imagine we want to draw that there. Okay, let's imagine this problem asks us to work out this curved part here. But we're not told it's a semicircle, we're not told it's a quarter circle. So identifying this fraction at the start is going to be a wee bit more tricky. Okay, see in this question here, see this yellow part that we're going to want to work out? This yellow part here, this is what is referred to as the arc length. That's the length of the arc around this section of the circle. Okay, let's imagine, let's say this is 100 degrees. And let's say that our radius is 10 centimetres. So remember before, if we wanted to work out the circumference, we would do pi times diameter. But if it's not a full circle, we would need to have a fraction that would go in here that would multiply it to give us the correct arc length. I want us to now link back to, for example, here. We need to know one thing, and that is the angles around a point. I'm just going to do a wee drawing here. Okay, when we learned angles in the past, we know that the angles around a point is equal to 360 degrees. Okay, so see if we wanted to work out this full circle here. This is technically, we've got the full 360 degrees. So although there is no fraction here, technically we've got 360 over 360, which simplifies to 1, which multiplies this in here. Here we've got a semicircle. Okay, so we've got a straight line, so that means that this angle in here is going to be 180 degrees. So the fraction that we multiply by is 180 out of the 360. And then when you simplify that, you can get a half. Similarly here, we've got a right angle, which is 90 degrees. So here we've got 90 out of 360, which is a quarter. Okay, so these angles here, we just instinctively know that they're a half or a quarter. But see here, we don't know what fraction this 100 represents. But if we link it to what we've just done up here, we know that that is 100 degrees out of 360 degrees. So we could write that as 100 over 360 times pi d. Okay, but instead of writing circumference, we're going to write arc length. Okay, so it's the fraction of the circle. You take the angle at the centre divided by 360. Okay, so let's work through this one. So the arc length is going to be 100 over 360 times pi times 20. Remember, the radius is the distance that goes the full way across. You need to be careful on how you're using a calculator here. Make sure you're using the fraction button. Okay, so we've got 100 over 360 times pi times 20. And to one decimal place, that's going to be 17.5 centimetres. So see, generally, we can generalise this to work out the arc length. What we can do is we can take the angle and we can consider that as a fraction out of 360, then multiply it by pi times the diameter. Okay, we're going to do two more examples. Let's go for something like this here. Okay, so we want to work out the arc length. Remember, this part here is the arc length. The curved part is the arc length. And if I just zoom in here, let's say that this bit here is 22 degrees. Should be able to zoom out, there we go. And let's say that my radius is 3.1 centimetres. That would be from there to there. Okay, so step one, if you want to do this, is you write down your formula. So to work out the length of the arc, you do your angle over 360 times pi d. So here the angle is 22, 22 over 360 multiplied by pi times 6.2. So do that on a calculator, 22 divided by 360 times pi times 6.2, and if we're to do this to one decimal place, that would be 1.1 centimetres. Sorry, 1.2 centimetres. Okay, so we're essentially saying that this bit here, this curved part, if we flattened it out, that curved part there would be 1.2 centimetres. Okay, we'll do one final one, because sometimes a question may ask you to calculate the perimeter. Calculate the perimeter. Okay, so let's have a diagram. Let's go something like this here. And let's say we're told that this bit here is 72 degrees. And let's say that this bit here is 22 centimetres. And that is from there to there. So the perimeter of a shape is the distance around the outside. Okay, so what we need to do is we need to work out what this length is. We need to work out this arc length. But the perimeter is the distance around the full shape. So we would then need to add our 22 here. And this length is also 22 because it's the radius. So I'm going to start this out. I'm going to write perimeter. Perimeter equals 22 plus 22 plus blank. We need to work out the blank being the arc length. Okay, so the arc length, we do our angle over 360 times pi d. So that's going to be 72 over 360 times pi times 44. 72 over 360 times pi times 44. Let's go, that's going to be 27.6 centimetres to one decimal place. So that is this length here. Okay, that length there is 27.6, so therefore the perimeter altogether is going to be 22 plus 22 plus 27.6. And that is going to give us 71.6 centimetres. Most important thing that you need to be able to do is you need to know this formula, and more importantly identify when to use this formula, because we're going to be looking at a mixture of different skills quite soon.